Hello everyone. I hope we're all doing really well, and I hope you're ready for some more National 5 chemistry. Today we're going to be looking at our last, thankfully, I can hear you all saying, looking at our last homologous series, which are called the carboxylic acids. We need to know the normal kind of things about the carboxylic acids, like we need to know about all the other homologous series. We need to know how to draw them, how to name them. We need to know the functional group that's present in the carboxylic acids, and also have a look at maybe an everyday example of carboxylic acids, and maybe a couple of reactions that carboxylic acids can undergo. Okay then, let's kick things off with the functional group of our carboxylic acids. Basically, how we're going to spot if a molecule belongs to the carboxylic acid family. And they need to contain this functional group here. Well, they'll have a carbon double bonded to an oxygen, and they'll also have an OH group. So we've got C double bond O OH, and this is the functional group of the carboxylic acids. We'll always find it at, at carbon number 1 on the molecule. We'll talk a little bit more about that later. And this has a specific name, just like how in the alcohols that we looked at last video, we said that the alcohol group or the OH group is really called the hydroxyl group, and that's the name we should use. In the acids, if we see the C double bond O OH, or sometimes in a shortened structural formula, we'll see it as this Q group, we have to know that this is not the acid group. We wouldn't use that word. The word we'd have to use is the carboxyl group. So this is the correct name for identifying this functional group. Here it is in the full structural formula. Here it is in the shortened structural formula. C double bond O OH, and it is the carboxyl group. And as usual, we're going to have to know how to name carboxylic acids, how to draw them. And whenever we're naming a carboxylic acid, the end of the name is always going to be anoic acid. So quite a longer name than what we're used to. We're normally just used to maybe 3 or 4 letters, a little bit longer than normal. And also we must always include the acid part. Sometimes people forget, they might just write methanoic. You have to put in methanoic acid, propanoic acid, etc. So this full part is the ending for our carboxylic acids. Let's look at a couple here. Let's say we had a carboxylic acid with 2 carbons in it. I know straight away, looking at this molecule, that it's going to be a carboxylic acid because it contains the carboxyl functional group C double bond O OH. And as always, we just approach this like we'd approach naming any molecule. We start with our normal steps, find the longest chain of carbons that contains a functional group. We've only got 2 carbons here, so this is obviously the longest chain, and the prefix for 2 carbons is eth. Now we have a look at the molecule, decided that it's a carboxylic acid because it has the carboxyl functional group, so it's going to be eth or eth anoic acid. Quite straightforward. Ethanoic acid. Now, ethanoic acid is quite a good one just to kind of commit to memory as a maybe everyday example of a carboxylic acid. So, ethanoic acid is one that you would use if you were maybe going to the chippy and you said to the guy, can I get some salt and vinegar on my fish and chips? What you're really asking for is some salt and ethanoic acid. So, ethanoic acid is just vinegar. That should tell you something about the properties of the carboxylic acids. If ethanoic acid is vinegar and we can consume vinegar and eat it and put it on our food, then these acids would be best described as being weak acids. If we cast our mind back to our Unit 1 chemistry, we talked about acids and alkalis and maybe strong and weak acids. Carboxylic acid's a good example of a weak acid, and maybe actually while we're just on that train of thought, talking about our, our kind of Unit 1 chemistry from last year, it's worth us talking about a reaction that we can do with our carboxylic acid. So we can react a carboxylic acid with a base, like an alkali, and it would be a neutralization reaction. We use the base to neutralize the acid and produce our salt and water. So it's worth just kind of keeping in mind that we can link these two topics together now in terms of our first topic and our second topic, and think about carboxylic acids used in a neutralization reaction to produce our salt and water. Okay, let's wrap things up now with a couple of examples of just naming and drawing some carboxylic acids, just so we're 100% sure on the kind of intricacies involved when naming these molecules. Now, I think they're actually a little bit easier to name compared to like, our alcohols or our alkenes, in the fact that we don't actually have to number the functional group. And if we remember from earlier in the video, we said that all our acids contain this functional group here, which is the carboxyl functional group. So if we see this, the C double bond OH, I know straight away that this is going to be a carboxylic acid. And even better, I also know that where I find this carboxyl group, that will always be on carbon number 1. And so this must be carbon number 2, number 3, and carbon number 4. So wherever we find that carboxyl group, that is always going to be carbon number 1. Sometimes we can see it drawn on the left-hand side as well, just kind of facing the opposite way. And if we had this molecule, then again, it just means that wherever we find a carboxyl group, that's going to be carbon number 1. So there's a couple of things to keep in mind there. And as I said, I think they're a little bit easier to draw and name than our alcohols, purely because of this reason here. That's always going to be carbon number 1. So let's find the longest chain. 1, 2, 3, 4 carbons. So my prefix for 4 carbons is bute. It's got a carboxyl functional group. It's a carboxylic acid, so it's going to end in anoic acid. Make sure we remember the acid part. And then we've got our usual suspect. We've got a branch, a methyl branch on, in this case, not the second carbon. So this is the mistake that a lot of people will make when naming this molecule. They'll just assume that this is on the second carbon. No, please remember that that carboxyl group is carbon number 1. So this must be 3-methyl butanoic acid. Okay, let's spice things up a little bit in this second example. You might be sat there thinking, what is this? Well, don't worry, just approach it with the normal steps. As always, find that longest chain of carbons that contains a functional group. So the reason I've included this example is for this reason. You could find a pretty long chain here of carbon atoms that goes like this. And sometimes people, when they're trying to find the longest chain, especially in an example such as this one, might go, okay, there's the longest chain. And now they're going to get stuck, going to get stumped, because they've made the functional group as like a branch. And we can't do that. This cannot be our longest chain of carbon atoms because it does not include the functional group. So we can't have that numbering system. And also, with any carboxylic acid, we always know that wherever we get the carboxyl group, this has to be carbon number 1. So that makes numbering this chain a little bit more straightforward. And there is our longest branch. It's in a kind of zigzag pattern, but that doesn't matter to us. We've got 5 carbons in the chain, so it's going to be pent. We've got the carboxyl functional group. It's going to end in anoic acid. Move that acid over a little bit. Remember, no need to put any numbers in here because it's always going to be carbon number 1. And then we've got 2 methyl groups. So I'm going to write down the word methyl because that's the type of branches I have. And also remember to put in di because we've got 2 methyl branches and they're both on carbon number 2, 2, 2 dash dimethyl pentanoic acid. Quite a tricky example there, but follow the steps and we'll be right as rain. And let's end the video with this final example where we're just working backwards. We've got a name and we've been asked to draw this carboxylic acid. So if you want to have a go, feel free to pause the video right now and have a go yourself. And here is the answer. Remember, I think the best way to draw any molecule like this is to kind of start from the end. We've got hex, so I'm going to put in straight away 6 carbon atoms, because I know that hex means my longest chain is going to contain 6 carbon atoms. Anoic acid, well, that means it's a carboxylic acid. It's got the carboxyl functional group, which is a C double bond O OH. Well, that's a scrappy H. Change that. C double bond O OH group. And again, I've got a choice in where I can put it. I can either put it on the left hand side, like so, or I can put it on the right hand side. Now, I prefer to put it on the right hand side. I think it just looks a little bit nicer. But if we do that, we need to be 100% sure that this is carbon number 1. And then let's deal with the first half of the name, 3,4-dimethyl. So carbon 1, carbon 2, carbon 3. Going to have a methyl group on the third carbon, and also a methyl group on the fourth carbon as well. And then go ahead and fill in the rest of the hydrogens until I've got a nice saturated molecule, making sure, as always, every carbon contains 4 bonds. I'm just going to rub out that little one there to make it look a little bit nicer. And there we go. 3,4-dimethyl hexanoic acid. Okay guys, that's the end of the vid. I hope it was useful and I hope you enjoyed it. See you later.